on thermochemistry. For your last video, we have a math topic that we're going to discuss, and the math topic is called delta H. It's actually delta H for the reaction, and when you are finding your delta H for the reaction, it's actually looking at how much heat is in the reactants versus the products, and you're going to figure out that total heat exchange that's happening in your reaction overall. So what you have in your delta H value is you're going to see how much heat is absorbed or released, so positive or negative, in kilojoules for the reaction overall. And when we look at this, it's actually based off of the balanced reaction, because your balanced reaction is going to tell you how many kilojoules of heat per mole that reacts overall. So we can figure out how much heat is absorbed or released in a chemical reaction, but that is for the particular mole amounts that are present. We want to know, if we use whatever particular amount in grams, how much heat gets absorbed or released on the chemical reaction based off of a certain mass of a reactant. So when we do this, we're going to take your grams that are given and convert it to moles. Remember, moles are no good for your stoic problems, and we're going to set these up in a very stoic way. The difference here is you're not going to have a mole ratio. You're going to use your delta H value, and the delta H value is dependent upon the moles of the chemical reaction overall. So we have to balance the reaction, and then once we balance the reaction, whatever coefficients are out front, that is equal to the delta H value. So if you have 3 moles reacting of your reactant, that 3 moles is for your overall delta H value. So with your example problem that I have here, ooh, I opened the wrong thing, sorry. There we go, I saw the circle. In this one, it says how much heat is released when 18.6 grams of hydrogen reacts with excess oxygen according to the following reaction. So this is saying that we have 18.6 grams of hydrogen reacting. We want to know, based off of this reaction with your delta H value given, how much heat is being released. So I'm saying released because it's negative right there. If it was absorbed, that would be positive. Your first step when we do these is we have to balance out the reaction. So we're going to put a 2 right there and a 2 right there. And how this reads is, if I have 2 moles of hydrogen, that's how much heat gets released. If I have 1 mole of oxygen, that's how much heat gets released. Or if I have 2 moles of water, that's how much heat gets released. So everything is going to be based on the coefficient is equal to the amount of heat released. So first step, you're going to have to take your grams and you're going to have to turn it into moles. So if we want to go from grams into moles, we use the molar mass of hydrogen. Hydrogen on the periodic table is 1.01. There's 2 of them, so we have 2.02 grams for the mass of 1 mole. So then, now that I've taken my grams and turned it into moles, now I can use my moles of hydrogen and set that equal to my delta H value. So in this case, I have 2 moles of hydrogen. And with those 2 moles of hydrogen, that is equal to negative 571.6 kilojoules. So what this overall is saying is, instead of having 2 moles of hydrogen, I have 18.6 grams. So I took my grams and turned it into moles, and then I used that ratio of 2 moles of hydrogen is equal to my delta H value. If it said something about oxygen instead of hydrogen, I would have used a 1 right here, because there's a 1 in front of my oxygen, but the question asks for hydrogen. So now all I need to do to get my answer here is do the math. So when I do the math, I'm going to get my calculator, and I'm going to multiply across the top 18.6 times 1 times negative 571.6 divided by 2.02 times 2. So on this problem, I'm starting with 3 sig figs right here. If I start with 3 sig figs, I need 3 sig figs in my answer. So when I get my answer here, it's negative, because it's still releasing energy, negative 2,630 kilojoules of heat is going to be released when we use 18.6 grams instead of 2 moles. So with these problems, you're going to take your grams, convert it to moles. Then you're going to use your balanced reaction and set your coefficient of your amount is equal to your delta H. Use that in your last conversion factor. If you guys have any questions, ask. Otherwise, I hope you have a great day.